Right, today's Unit 8, Day 1. Last chapter we solved quadratics by graphing. So this whole unit and Unit 10 will be all different methods in solving quadratics algebraically. We'll review a little bit how to do that graphically, because remember, we always want to make sure that we use our calculator as a nice resource for us. So it's always a good idea to use that in order to check your answers. Okay, so before we get into the lesson, I would like to refresh your memory on factoring. Okay, so factoring. So for question number 1, so we have x squared plus x minus 6. Okay, so our a value is equal to 1. So remember, we're looking what multiplies to negative 6 and adds to a positive 1. So remember, our factors are always going to look like this. So I have an x and an x. I have a negative product, so one will be positive and one will be negative. And then the only factors that would get me to a 1 would be 2 and 3, 2 times 3. And the larger one takes the sign. So we'll have a plus 3 and a minus 2. And remember, you can FOIL to check yourself. Okay, the next one, hopefully you see we have only an a value and a c value, so hopefully you're thinking dots. Okay, so we have our two factors. Square root of the first would be an x. One gets the plus, one gets the minus, and the square root of 16 is 4. Okay? And lastly, again, product of 25 and sum of negative 10. So again, x with an x. So the only product of 25, so I know they both have to have the same sign, because two positives multiplied together is a positive, and two negatives multiplied together. And I know the only way to get a product of a positive and a sum of a negative would be two negatives. So minus 5 and minus 5, or we could write x minus 5 squared. Okay, so basically the main purpose of this whole entire unit is going to be finding the zeros or the roots, x-intercepts, etc. Okay, and sometimes I'll just say find the solutions. Okay, so again, we're solving these algebraically. Okay, so you can put them in your calculator if you want, but we are doing this all algebraically. Okay, so our steps before we get started, if we can just go over those. So our steps are, we going to first set them equal to 0. Set them equal to 0. Then we're going to factor. Okay, so the zero product property says that each factor should be set equal to 0. So what you're going to see is our factors are going to actually give us our zeros, or our solutions, or our roots. Okay, so then we're going to write, you can either write them as like coordinates, or when you say braces, these little brackets of braces. Okay, so let's try it out. All right, so again, instead of an f of x here, what we're going to do is we're going to say x squared plus x minus 6 is equal to 0. And remember, that's because f of x is equal to y, and all of our zeros, the y coordinate is equal to 0. Okay, these give us our roots. Okay, so now don't pay attention to this 0 first. First, we're going to factor this. So we already factored it above, so I'm actually just going to use that. Okay, so I get x plus 3 and x minus 2. Okay, so now what you're going to do is I'm going to do x plus 3 equals 0. So set one factor equal to 0 and the other factor equal to 0. and then you solve for x. So x equals a positive 3. And x equals, negative 3. And a positive 2. So again, my final answers are 3 and 2 are my roots. Those are my solutions. Okay, simple as that. And if you take out your calculator and check it, so I put this in my calculator, and if I graph it, okay, you see it goes through negative 3 and positive 2. You can double check on the table. Negative 3 is a 0, and positive 2 is a 0. Perfect. Okay, let's do another one. So this one already is set equal to 0, but I'll just rewrite it. Okay, so again, step 1, we factor. So remember, these are difference of perfect squares, so we get an x plus 4 and an x minus 4, and that is equal to 0. So then we take each of our factors and set them equal to 0. Because remember, our factors tell us our roots. So x equals negative 4 plus 4. Positive 4. Okay, so negative 4 and a positive 4 will be our solutions. And remember, this right here is where they would cross. So you'd have your graph, you'd have a negative 4 and a positive 4. Okay, and you can always double check with your graph. Okay, again, we already factored this. When we factored it, we got x minus 5 and x minus 5. So x minus 5 equals 0. X minus 5 equals 0. Hopefully you're noticing that these two will be the same answer. So if both of your roots are the same, in your bracket you can just write the number 5. Okay, that means there's just one solution. Okay, so now we have a multiple choice question. So we have the zeros, okay, again, same thing as roots, or x-intercepts, are negative 6 and a positive 5. What could be Jack's function? So first of all, I know that one has to be positive and one's negative. So I'm going to cross off choices 1 and 4 because those are both different. Now what we have to notice is, well, this says a minus 6 and a positive 5, so you might think the answer is number 2. But remember, what we do to see what the zeros are is we set these factors equal to 0, and then we solve, right? So this actually equals negative 5, and this equals a positive 6. So that one didn't work. Okay, so obviously we know this is the answer, but let's just try it out. Okay, so x minus 5 and x plus 6 equal to 0. So x minus 5 equals 0. Add 5 to both sides. So x equals a positive 5. And then negative 6, which is our answer. Okay, not too bad. Okay, so now we have to factor this. So hopefully you're seeing that this has a 2, so we're going to have to do our x method. So 2x squared plus x minus 3 equals 0. So you could FOIL these if you want to get back up here. It's up to you. But I'm just going to do this quick. Okay, so the AC method says a times c, so that'd be a negative 6 and a positive 1. So I'm going to get 3 and negative 2. Okay, so I get 2x squared plus 3x minus 2x minus 3 equals 0. All I can take out is an x, so I'm left with 2x plus 3. And all I can take out here is a negative 1, so I'm left with 2x plus 3. So my factors are 2x plus 3, and then the leftover. And lastly, set these factors. Oh no, don't even have to. Perfect. Okay, so our answer is, where's my pen? Okay, 2x plus 3 and then x minus 1. Please, you guys, when you do this work on the side, take the extra second to make sure you circle the right one. Okay, a lot of you guys are making silly mistakes on your tests. Okay. Okay, in the equation x squared plus 10x plus 24, x plus a and then x plus b is an integer. Find all possible values of b. Okay, so let's see. So what I'm going to do is factor, okay, and you'll see what you get. Okay, so when I factor this, again, I want product of 24 and a sum of 10, so x plus 6 and x plus 4. So remember, these don't matter, so b can equal either 6 or 4, okay? Because it doesn't say that, so both of them are positive, so remember it doesn't matter, so I can write x plus 6, x plus 4, or I can write x plus 4, x plus 6. Okay, these are the same exact thing, so this would be A, this would be B, or this would be A and B. Okay, so my possible values for B are 6 and 4. And the last one we're going to do before I let you do your homework. So we want to find the roots of the equation. So I have x squared minus x equals 0. And again, this is all done algebraically now with any graphing. So hopefully you notice you cannot factor this right now. First we have to take a GCF out. If I take a GCF out, I get x times x minus 1. Okay? And the reason why I wanted to do this one is because whenever you have your like a GCF that you took out, you have to set that equal to 0 as well. So one of my roots is actually 0. And then I get x minus 1. So if I added 1, so x equals 1. So my solutions are going to be 0 and 1. All right? And again, if you wanted to graph that, I'll graph one more so you guys can look at what you're trying to check for. So I have x squared minus x. I'm going to graph it. Okay, and you see that it goes through at 0 and 1. Okay, so for homework / classwork, lesson was not that long today. Okay, so you're going to do page 3, number 8 to 10. And again, that is one of the ways that we can solve quadratics algebraically.